So the topic tonight is using digital apps to plan and visualize landscape photography. And this really is mostly for landscape and cityscape and nightscape type photography. Uh, the idea is that although you can take a picture at any time in any light, and if you've got a good subject, you can probably make a good photograph. But there are certain times of the day or the night, like sunset, sunrise, moonrise, or Milky Way appearance, that give you special opportunities to put that lighting on a particular foreground that you're interested in. So that's what we're talking about tonight, is some apps that are available that are designed for photographers to help you plan photos for those special lighting situations. Now I've stolen the heading of this slide: imagine, plan, shoot. That's kind of a tagline that the PhotoPills app folks use in advertising their app. But I thought it was a good way of summarizing what I'm talking about here. So basically, smooth this. Basically, I see these apps as helpful in three main categories of situations. First, just in general, to understand how the light, either from the sun or the moon, interacts with the terrain to help create dramatic images. Second is to help you to, when you imagine a composition at a specific site, whether you're at that site or you're at home and just, maybe you've been there in the past, or maybe you've seen it on a map, you can use these apps to help you determine when the best time in terms of lighting might be available to you. And the third is to say you're going to be in an area, say you're going to be in Monument Valley or something, and you're going to be there at a specific date, but you want to know when and where in that area the best light might be, whether it's sunset or moonrise or whatever. So that's another category that these apps can help you visualize. So before we get into the apps themselves, I want to talk a little bit about light and then a little bit about some definitions that these apps all use. So this diagram kind of represents the sunlight around the time of sunrise or sunset. So 0 degrees is the horizon if you assume that you're looking over the ocean or another flat area at least. After the sun sets, of course, we have twilight. And there are definitions of 3 phases of twilight that are actually used by professional astronomers and sailors and so on. If the sun is less than 6 degrees below the horizon, we call it civil twilight. Basically, that's the time after sunset when there's still enough light out for normal people to be able to see and still do things outdoors. So if you think about the sky, we've got a 360-degree sphere. So 6 degrees is a pretty small fraction of that sphere that the sun goes around. Then the next 6-degree period is nautical twilight. And I've heard that defined as a period when most of us probably are finding it difficult to do things, but sailors can still see land if there's land on the horizon, that sort of thing. And then the final stage is astronomical twilight. So between 12 and 18 degrees, when the sun is 12 to 18 degrees below the horizon. And the significance of that is that when the sun is 18 degrees below the horizon, it's dark enough for astronomers to do serious work. And in our situation as photographers, that's what it's dark enough to do Milky Way photography, for example. You will see some bright stars before then, but to see faint stars or the Milky Way, you need to be close to that astronomical twilight. So in the morning, you have the reverse as the sun rises. First, it's, of course, very dark night, then astronomical twilight, nautical, and civil. And those are, as I say, those are all standardized definitions. As photographers, we have a couple of other concepts that we talk about that are less formalized, but one of these is the golden hour, which some people define as when the sun is less than 6 degrees above the horizon, but more than 4 degrees below the horizon. And you know the kind of light we get in that period. We get very warm light as the sun sets, and then we get that beautiful twilight early after the sunset. And then the final few minutes of civil twilight is often called the blue hour, when you get that really interesting blue color in the sky. That's a great time to take nightscape and cityscape photos. So those are a few lighting concepts that these apps keep in mind when they're the concepts that all three of these apps use to define the light. So important to understand what they mean. I had a question about whether these slides will be available afterwards. And yeah, I'll make a PDF file of this presentation available. Okay. Next thing I want to talk about are a few definitions, because I'll be using them as I discuss the apps. One is the azimuth. The azimuth is thinking about compass directions. If you think about north as being 0 degrees, the azimuth is the direction that an object like the sun or the moon or a star makes if you're the observer between you and the North Pole, or between that object and the North Pole. That angle is the azimuth. So here in the Northern Hemisphere, we normally are going to talk about north is 0 degrees, east is 90 degrees, south would be 180 degrees, west 270 degrees, and then back to 360 degrees is due north or 0 again. So that's azimuth. Second concept is, or second definition is altitude. Sometimes it's referred to as elevation. Again, that's usually defined as an angle. If you think about the horizon, if you're in a flat area, the horizon is 0 degrees. Straight up would be 90 degrees. And so the altitude above the horizon of a star or the sun or the moon is an important thing to know if you're trying to photograph it. Third definition is ephemeris. Ephemeris is just a source of information. It could be a table. It used to be that we would look this up in an almanac or something. It could be a table, or it could be a set of calculations like these applications use that are used to define the orbit of the sun, the moon, stars, satellites, the comet most of us saw recently. So those can be, the ephemeris for those objects can be defined as a set of equations, and these applications use those equations to tell you where in the sky a given object will be found at a particular time. So the three apps that I'm going to be discussing tonight, and again, looking back at our poll. It looks like a few of you use Photographers Ephemeris and Google Earth, couple photo pills, and a lot of you have a lot of, shall we say, spontaneous photography. Anyway, the three applications are photo pills, Photographers Ephemeris, which is often abbreviated, and I'll use this tonight, TPE, and Sun Surveyor. And of the three, I think Photographers Ephemeris has been around the longest. And I know personally, I have the most history with that. So I've used it a lot more. I know it a little bit better. And I probably have a certain bias towards it for that reason. And the third application is Sun Surveyor. Of the three, I've got a table here, and again, this compares the three of them. Again, I'll make these slides available so you don't have to try to read the tiny print on here, but I will make a couple of comments right now about it. They're very comparable apps in many ways. They all are available for both Android and iOS devices. However, TPE is also available as a free version that you can use in your web browser on a computer as well as a mobile device. So it has a slight advantage there in that there is a free version that you can use and do, interesting planning things with without having to buy something. These are not huge expenses. The apps for photopills, Sun Surveyor, are like $10. TPE is $10 for iOS application. Their Android version is cheaper, but it is a little bit more limited. So they all, at their heart, have an ephemeris that tells you information about the sun, moon, and Milky Way, and sometimes stars, when you can see them, where you can see them in the sky. TPE and photopills also have something that I'll talk about in a few minutes called geodetics, which is very useful. Sun Surveyor doesn't really have that, at least not in a way that I've been able to figure out. So that's a little bit of a disadvantage there. All three of them also have a terrific feature called augmented reality. Augmented reality just means that you can use your phone or your tablet's camera to view the terrain where you're standing, and the application will overlay the path of the sun, the moon, or the Milky Way on that image that you're looking at. So you can get a really good feel for where those stellar objects will be. And that's especially useful if you're trying to line up a photograph where the sun or the moon, for example, would be in a very small notch between two mountains or that sort of thing. They also, all three have a night mode to help you visualize Milky Way. And they have a feature that is usually called visual search, which is not a very good name for it, but it's a very useful feature. Visual search allows you to say, okay, I see this mountain over here. When during the year would I be able to line up a moonrise over that mountain? And you can search by where you want the moon to be, essentially, or the sun, or the Milky Way. So again, I'll make this entire table available as a PDF with the presentation. I'd also point out there is a pretty good comparison of photopills and TPE, at least, at this website that I've cited here. So that's something to look at too. In terms of if you've never used any of these applications before, but you think you might have a use for them, I guess I would recommend that you might start out with the free web version of TPE. And then after that, decide what you need. If you want to jump right in and buy something. If you have an Android phone, I probably would not recommend TPE because it's much more limited than PhotoPills, for example, or Sun Surveyor either, as far as that goes. So again, they all can do a lot of the same things. PhotoPills has a few extra bells and whistles, which are useful but kind of peripheral to the main function of the application, in my opinion, but they are useful. So next up, I'll show you a comparison of how these three applications look on a telephone, a mobile phone, on my iPhone in this case. So from left to right, I have Sun Surveyor, PhotoPills, and TPE. And I tried to line them all up at about the same location. It's actually Deb's School north of Pagosa Springs up the Piedra Valley. And I'll get into what all the lines mean in a little bit more detail in the next slide. But basically, the yellow and orange lines tell you where the sunrise and the sunset is, and if the sun is above the horizon, what angle from your observation point it's located at. The blue lines are the same thing for the moon. I don't know, for some reason for PhotoPills, I managed to pick a winter date instead of the summer date that I used for the other two, but same concepts. In these three images here, I gave them all the same kind of map, which is a Google terrain map, but you have a variety of map choices available. You can look at satellite images, street maps, topographic maps, and so on and so forth. On the top, on Sun Surveyor, there's information about your location. On the bottom, there's information about when the sun comes up and where it is now. And all three apps at the bottom have a timeline that allows you to scroll through the day or the night to see how the sun or the moon will be moving on the horizon as you plan your shots. Again, very similar in the other two apps. Little differences in the interface, little differences in the amount of material shown. And you can, with all of these, you can customize them a little bit. This little black tab on Sun Surveyor, if you press that, this bar showing the sun information will be shrunk down to give you a little bit larger map. And you can do the same kind of thing with PhotoPills and with TPE, just to maximize your map information. So, oops, I want to go back. As I was putting this presentation together, I originally was going to do demonstrations in all three apps, but it turns out would have taken a long time to get them all. And so I'm really not going to do anything in Sun Surveyor, but I did want to point out a couple of nifty features that it has. First of all, its visual search capability, that is to say the ability to look at a mountain or a building or an arch or whatever and say, when during the year might I be able to photograph a moonrise or a sunrise at that location? Sun Surveyor's visual search is in some ways the best of all three, although they all can do it, but Sun Surveyor's is really nifty. Second thing is that its ephemeris is very, very detailed. It has a tremendous amount of information. One of the things that I really love about it is part of the ephemeris has what they call photo opportunities. And I've made a screenshot here on the right side of the image of what that looks like. So it lists things like, okay, on September 18th, there's going to be a crescent moon at sunset, and it'll be low on the horizon just as the twilight is coming in. So it's a good time to photograph the crescent moon. And the 18th through the 21st are great days for good Milky Way photography. It tells you that the Milky Way will be visible, that the moon will not be up, so you don't have any bright moon to worry about. And it gives you the time period when the Milky Way core will be visible, which is the most photogenic part of the Milky Way. And then on the 29th, it tells us that there's going to be a full moon right at sunset. So again, a great time to photograph a full moon. And that's a really nifty feature. If you're someplace with interesting terrain and you want to think about what you might photograph on a given day, this is really a useful feature. And the third thing that Sun Surveyor has is it can also use, in addition to maps and in addition to augmented reality, it can use Google Street View on those areas where that's available. And that gives you the ability to take the images from Google Street View and overlay the movements of the sun and the moon on any given day onto that image. So you can plan photographs remotely if they're covered by Google Street View. I know TPE doesn't have that ability, and if it's in PhotoPills, I haven't found it yet, but it's a major feature in Sun Surveyor. So those are really useful things about that app that I won't have time to talk about in detail tonight. And the next thing I wanted to show you is just to go over the kinds of controls that all these apps have when you're looking at a map in them. And in this case, this is an image from the web version of TPE. That version is nice if you have a computer with a decent sized screen, because you can look at a lot of detail on the maps. But in any case, the major features that all the apps share is there is what we call a primary pin, or maybe it's sometimes called an observer pin. It's red in PhotoPills and TPE and green in Sun Surveyor, but it's the same idea. That's your point of observation, where you have your camera located, let's say. There's a set of yellow-orange lines that represent the sun. So in TPE, there's a light yellow line that's pretty thick, that's sunrise. There's an orange line that's thick, that's sunset. And there's a thin orange line that represents the angle of the sun on the horizon during the day. And you can select that time from the timeline down below. Similarly, for the moon, there is a light blue line for moonrise and a dark blue line for moonset, and a thin blue line would be visible if at this particular time, if the moon were up, showing its location on the horizon. So that's the sun and the moon positions. Next thing that all of them are going to give you is an opportunity to set the date. When do you want to make that observation? Are you looking for information for right now, or for next July when you're going to be in Glacier National Park, let's say? So you can set the date, pretty much any date in the future or in the past as well, as far as that goes. On the far right, there's information about the place where the red pin is set. It usually will give you the latitude and longitude as well as the elevation. Down below, there's what TPE calls an event timeline that shows you where interesting things are going on in the sky, like moonrise, transit of the sun, that is when the sun will be at its highest position in the sky for the day, golden hour light, sunset, civil twilight, nautical twilight, a crescent moon at a particular time. And all of these, it gives you information about the azimuth and the altitude. In the case of the moon, it tells you the percent the moon is full. So a lot of good information there. And again, on the mobile devices especially, you can collapse this information to make room for more map data. Below that is the timeline. Timeline has these curves in orange and blue, and those represent the movement of the sun, basically the altitude of the sun above the horizon. Here it's below the horizon. 0 degrees is this black line. At sunrise, it crosses that line and rises in the sky. There's a blue line at the bottom that will move you through the day. So as you move, you get a little box here that tells you what's going on in the sky and what angle of azimuth and altitude the sun and the moon are at that particular time. So lots of good information. The final thing, and we'll talk about this in more detail later, there's a secondary pin available in these apps, or at least in TPE and photopills, can be called the secondary pin or the geodetics pin. And that allows you, if you put it on an object, like I've got it here on Navajo Peak, which is an example I'll run through in a minute, that allows you to see, relative to the position you're at over here at the red pin, how high above the horizon is this feature on the landscape, what azimuth it has and what altitude it has. And that's helpful because if you want to take a picture of a moonrise, say, or a sunrise at this position, or a Milky Way, you want to be sure that those objects are above the mountain that you're looking at. Another area where this is important is, as you know, if you've lived in the mountains for any length of time, if you look up and find that, oh, sunrise is 6:50 this morning. So you get up at 6:50 and there's no sun to be seen. It might be 10 or 20 minutes before the sun clears those mountains. Well, this geodetics information can help you understand how long it will take for the sun to actually get over the mountain. So with that, I'm going to attempt one of a series of demonstrations. I believe I have 6 altogether that will show you how these applications can be used to help you plan good photographic opportunities. And I'm going to start with something very simple, and I'm going to use the photographer's ephemeris, which maybe is the simplest version of these 3 apps. So this is going to require me, as I do these demonstrations, I'm going to be switching between different applications on my computer and my iPad. I hope it all works. So I'm going to go to my web browser right now. Escape from that. And I'm going to go to full screen. Okay, so again, this is the web version of the photographer's ephemeris. It's free to use. If you do find yourself using it, you can sign up for a free account, which has an advantage in that you can then store locations that you might have interest in, so that you don't have to re-enter them whenever you use the app. Right now, I've got the pin set down in New Mexico at Bisti Badlands, and I'm going to reproduce a photographic opportunity from several years ago. It was one of the first outings that I led for the photography club. It was 2014, in fact. And I told people I was going to take them to Bisti Badlands and we were going to photograph full moonrise over some of the fantastic hoodoos in that area. So the first thing I'm going to do is go back in time to that date. So I'm going to go up here to locations. I have stored locations. There's a hoodoo there called manta ray. And I had seen that on earlier hikes and thought it might be a good foreground for a moonrise. So I'm going to go to that position. And I got to get the zoom interface out of my way. So I'm going to stick a pin at that location that I had a GPS waypoint for when I had hiked it in the past. Zoom in just a little bit. All right, so I'm now going to go to the date of that, which was 2014. Not 1014. And it was, I had noticed that the moon would be full November 6th. So we'll go to November 6th. And this is what the sunrise and sunset and moonrise and moonset looked like on that day. And this is the position of the manta ray hoodoo. So that was my planning. That was pretty much the extent of it, to tell you the truth, back in those days. I knew that we would have a full moon that would rise at an angle. Let's see, where's the full moon? Moonrise was at 5:21, and it would be at an azimuth of 72 degrees relative to north. And that'd be great. There's only one problem. When I looked at this, I realized that this would be about 10 or 15 minutes after sunset. Sunset was 5:11 that day. And I really wanted to have a photograph where I had the setting sun still illuminating the landscape, because the landscape there really picks up the sunlight and turns this really warm color. So I wanted to be able to capture that too. Now I know that often that happens the day before the actual full moon. So I just used the time controls and stepped back one day to November 5th, 2014. And now I see, okay, the moonrise is at 4:39 and the sun doesn't set until 5:12. So I've got half an hour between the time the moon comes up and the sun is still illuminating the landscape. And you can adjust the timeline here. You can see as the afternoon progresses from the movement of this thin orange line, how it will be illuminating the landscape. And that dark line that was showing up here kind of represents the direction of shadows from your position. So great, I can go down and I can get that photograph and all will be good. And it was, in fact. We'll go back to Keynote. So we got this photograph. I got this photograph, and as it turns out, in the end, I only had one person from the club who went with me. So it was kind of a bust as far as an outing, although we got some great pictures. We got that photo of the moon rising over the hoodoos at Bistai. And then a few minutes later, about 20 minutes later, I got this nice image of the moon during twilight, during that blue hour above the landscape there at Bistai. Whoops. Well, that was about this time that Bob Green, who was the one member of the club who was with me, started wondering how I was going to get him back to the car, because we had hiked out about a mile. How was I going to get him back to the car in the dark? I said, Bob, we have a full moon. The landscape is pretty well lit up. Plus, I have a really good GPS track of our hike in. So we did make it out, but he was pretty skeptical. So the next example I want to give, next demonstration, is sunset and sunrise at what I call Buckles Road Gap. This is a spot along Buckles Road where you're driving along the ridge. You've got great views to the east and northeast of Navajo Peak and V Mountain. And there's a place there where there's a gap in the ridge. And I know that at certain times of the year, the setting sun kind of shoots through that gap and lights up the mountains just before sunset. So I'm going to use, again, a TPE and show you an example of planting a photograph at that spot. So again, I'll go to my locations because I've got this stored as a waypoint. And here we are at, here's the Buckles Lake Road. Here's Navajo Peak. And here's V Mountain. And I'll change my date here to October of 2017. October 9th. This was another photo club outing. We'd had a pretty good time that afternoon. There were a lot of storms in the area, so the light kept changing. There were rain squalls, there were snow squalls. We had gone up the Navajo River Road and shot some interesting photographs up there. And then we went up Buckles Road, Buckles Lake Road, because I wanted to stop at this spot and photograph the light there. There's some great oak, Gamble's oak in this valley in between the observation point at Navajo Peak, as well as a number of aspen groves. And it was a good year for fall color that year. And I thought it'd be a great place to shoot. Well, we got there and these mountains were totally obscured by snow squalls. It was pretty chilly. Everybody left except Doug and myself. And we kind of alternated between getting out and taking photos of the storm clouds over the mountains, which were pretty interesting, and then jumping back into my Forerunner with the seat heater on to warm up. But I had seen a weather forecast that said that there was a pretty good chance that the clouds would clear right around sunset. And for once, they were actually right on that forecast. So the skies did clear, and that photograph you just saw of Navajo Peak was taken at that time. I would say the storm cloud photos were actually the better photos that day, but bear with me. In any case, we're going to plan that photo. We're going to say that we are going to shoot sunset. So I'll click on sunset here, and the thin yellow line merged with the sunset line, the thick orange line, because that's what it would do. But now let's go back just a little bit in time. And you see that orange circle appears. That orange circle is representing that you're within the period of time when the sun is less than 6 degrees above the horizon, or what we informally call golden hour. And the black line represents the shadow direction. And, at least in some relative way, the length of shadows that you might see. So you can see that as we get closer to sunset, we get into that golden hour period when we have that nice warm light. And that nice warm light is lighting up V Mountain and Navajo Peak, at least if the sky is relatively clear. Of course, we were still in storm clouds at that point. But you can get an idea of how the light will fall on the mountains. And you can also see that as you approach sunset, the shadows, of course, get longer and longer. And you have to be a little careful with that because this ridge that Buckles Road is on casts a shadow across the valley. So you really want to get it before the shadow creeps too far across the valley in most cases. But we got lucky that day, and the storm clouds did move out, and we got some nice photos after the cleared, as the storm was clearing, of Navajo Peak and V Mountain. But I want to show you another example of possible photographs from this same site. And to do that, I'm going to switch to using the mobile version of Photographer's Ephemeris on my iPad. So I'm going to get out of Safari, turn on the iPad. Bear with me just a second as I get this set up. Okay. So you should be able to see now my iPad screen, I hope. And let me go back to this. Dealing with the Zoom interface while making all of these switches is tons of fun. Okay, so I've already set this up so that my red pin, and I hope you can all see this, let me know if you can't. The red pin, again, is the gap there on Buckles Lake Road, and I'm going to try to set it up. Let's say I want to take a picture where the sun is just rising over Navajo Peak. I've got the date set to, I want to set the date. That's what I want to do. I want to set the date to today's date. Okay, so on today, you can see sunrise out there would be about 6:46 in the morning. Sunset would be 7:22. Sunrise this morning is a little bit north of Navajo Peak. So if you want to take a picture from this position of the sun coming right over Navajo Peak, this isn't quite going to do it. So there's a feature in these apps called geodetics that will help us to plan this photo. And in TPE, that's the gray pin. So I'll click on that. I get confused whether I should click on my iPad or the view of my iPad on my computer, so excuse me. Anyway, here we go. Gray pin. And what I want to do is I want to line up the gray pin with Navajo Peak. So I'll drag it over here. I'll zoom in a little bit so I can do it more precisely. and try to get it right on the peak. And that looks pretty close. I'll zoom back out a little bit. Okay, so the question I want to know is, when will the sun align with this gray pin? And when will it be high enough in the sky to be just clearing Navajo Peak? So there's some information given down below here once I activate that geodetic gray pin. First of all, it tells me that between the red pin and the gray pin, it's just a hair over 5 miles. And the bearing is 97 degrees, roughly. The peak of Navajo Peak is about 2,500 feet above the observation point, which makes an angle with the sky of 5.5 degrees. So we know then that when the sun rises, it'll have to get 5.5 degrees above the horizon before you'll be able to see it at Navajo Peak. That information is also shown kind of schematically as an elevation profile in the next part of the panel down here, where again, the red pin is here. You can see there's a valley, you drop down, then you come up and eventually to Navajo Peak. Where this shows solid white lines, those are parts of the landscape that you can see. Dashed lines are parts that are hidden by intervening terrain features. And I'd like to point out that for both photopills and TPE, this capability does require an internet connection, like cell phone connection or Wi-Fi or whatever, because there's a lot of three-dimensional information about the landscape that's just too much to store on your phone. So it's downloaded as needed. Anyway, this is what we've got today. And again, you can move through the timeline by dragging this dashed line down here from sun, on my iPad though, from sunrise through the day. And you can see that today the sun actually would have been on that bearing to Navajo Peak at about 8:18 a.m. But it would have been at that point 17 degrees above the horizon, almost 18 degrees. Now a useful small fact is that the diameter of the sun and the moon relative to our celestial sphere is about 1/2 degree. So if the sun is at 17 degrees and Navajo Peak is at 5 degrees, that's 12 degrees. That's like 24 sun diameters. So that wouldn't make a very interesting photo at all. You want it to be right there on that peak, basically. That's the picture that I'm visioning here. Well, when during the year would that happen? Well, you could step through the days and try to figure that out. But the other way you can do it is to use visual search. So in TPE, visual search is a button down here on the bottom, visual search. When you hit that button, it pops up a menu of choices you can make, things you can search for. Yeah, we don't want that. So in this case, it gives you an option of, do you want to look for the sun or the moon? Do you want to look for the exact moment of the sun rising or setting? Yes, we've selected the sun. Or do you want to look for it by its azimuth and altitude? In this case, we want to look for it by azimuth and altitude because we know those numbers for the from the geodetics pin. And in fact, TPE has been smart enough to automatically put those values in here for us, 5.5 degrees above the horizon and 97.4 degree bearing from true north. And it's suggesting a tolerance of plus or minus 2 degrees, which would be like 4 diameters of the sun. Okay, so that's probably okay for this search. There are some advanced options you could choose. I'm not going to get into those right now, but I'm going to set it to search for all times when the sun might be in that position over the next year. And then I'm going to do the search. And you can see it pops up quite a few suggestions for times you might be able to make this picture. One, it's got flagged with a green star, and I think that green star means TP is suggesting that that is a really good time to do this photograph. It's saying Tuesday, the 29th of September at 7:33 in the morning, the sun will be in a good position. So let's check that out. I'm going to tap on that result, and it's going to take me back to the map, and it's going to set the time for 7:33. Sunrise that morning is a little bit earlier. It's probably 7:02 or something like that. But at 7:33, the sun will be aligned with Navajo Peak. It'll be 5.5 degrees above the horizon, which matches the geodetics pin perfectly. And let's see, 97.4, it'll be within 1/10 of a degree of the bearing of Navajo Peak. So that looks like a fabulous time potentially to take that photo. Oh, and also if you slide the timeline around, it makes that orange circle glow. That orange circle is telling me that at that particular time, you're still within the so-called golden hour period. So the light on the landscape should be pretty nice besides. Okay, so that's using the visual search to find the position of a sunrise against an object in the landscape. Okay. So I'm going to switch back to Keynote. And I'm going to skip the slides that I would have used if for some reason the demo had not worked. Okay, the next situation that I am imagining here is I've noticed that from Echo Canyon Reservoir, there's a pretty good view of Square Top over the lake. This image was taken near sunset last fall when I was out there photographing birds with, I think, with Dave Anderson. Anyway, what would it be like to take a photograph of the moon coming up over Square Top with the lake in the foreground? That could be interesting. So in this case, I'm going to use photopills to plan a photograph of a moonrise coming up over Square Top as viewed from this location at Echo Canyon Reservoir. So we'll go to photopills. Launch it. Oh, well, conveniently, I've got the pin already located on Echo Canyon Reservoir, but let me show you how I did that. Again, I had a waypoint for that position, so I'm going to go down here to this load button, and I'm going to say I want a point of interest because I've got it saved as a point of interest, and I'm going to select Echo Canyon Reservoir, and there you go. And we'll just zoom in a little bit on the map, and you can see that that's where it is. Now it shows this as being on an island out in the middle of the lake, but it's actually a bit of a peninsula that goes out there. So I'm not going to get wet, I don't believe, getting there. All right. So now what I want to do is I want to use the geodetics control in photopills. And they are located in this panel here, where you've got this red pin and a black pin side by side. That's the geodetics information in photopills. So I'll turn that on, and you can see this black pin. And because I was playing around with this earlier, it's already located right there on Square Top mountain right where I want it to be, so that's handy. That'll save a little time. Um, so what I want to do now is I want to find when the moon will rise at that location as viewed from Echo Canyon Reservoir. And in PhotoPills, you do that using the Find icon down here at the lower left. So let's go to Find, and it pops up a bunch of information. We want to search for moon at azimuth and elevation because that's what information we have from the geodetics panel. Geodetics panel told us that we have an azimuth of about 73 degrees to square top, and its summit is at about 4.75 degrees. So we're going to do a search, and we're going to set a target range, date range, starting from this week until next September. And so we're going to start that search, and it's going to show us a table of results. This is very much like what we got in TPE looking for sunrise at Navajo Peak a minute ago. Well, there's some interesting things you can do with this table. You can sort it by any of these columns. So I'm going to sort it by the phase of the moon. So I'll just click on phase, and you see all these colored boxes. Well, it sorts initially the new moon. Well, I don't want to take a picture of a new moon. That wouldn't be very interesting. So I'll click it again to change the sort order. Now it's showing us a full moon. You can tell it's full because it's a full white circle. Down below, you have some moon phases that are crescents and so on and so forth. But a full white circle tells you it's a full moon on November 28th at 4:30. That could be a little bit of a problem because the elevation at that time is 4.05 degrees, and that may be about a half degree below the summit of the peak, but it still could be interesting. The color around the moon here tells you that that's going to be during golden hour, that red color. Below it is a full moon with a blue surround, and that's actually going to be during civil twilight, during the blue hour, basically. So as I did with TPE, I can click on one of those dates, and it'll take me back to the moon, and it'll show me that situation. So here we are on down here on November 28th at 4:30 p.m. The moon is just rising. The sun is already down. The sun set at 4:51 on November 28th. So we won't have, we'll still be in a bit of a golden hour, but not direct light. But that would be a good opportunity potentially. And again, you can move your finger through the timeline to see how that moon is going to look. And you can see that it's showing, as I move it, you see that dashed line. That's the path of the moon, the azimuth of the moon. And you can see initially it's dashed and then it becomes solid. What that means is that when it's dashed, that means that it's obscured by the landscape. So until the moon gets a little bit tricky to touch, past the summit of Square Top, it might not be visible. It might be a couple of degrees before you can actually see it. So this is a reasonable time to try to take a full moon photo out there, but it might not be right above the mountain. So I'm going to go back to the Find button here and bring up those results again. So it's kept those results alive. And I'm going to go to the next date, which it shows as November 1st of this year. And that's a blue hour photo. But the nice thing there is that the moon is 5.1 degrees above the horizon. So that's going to be a little bit above Square Top. So I'll click on that. And 6:34 on November 1st. And that boy, just as you clear square top, that line becomes solid. So right there, you've got a photograph of the moon rising above square top during blue hour. Um, so that could be a good photo. So that's how you use photopills to plan a moonrise shot against a specific object on the landscape. Okay, so another switch here. Um, we're going to plan a couple of Milky Way photo opportunities out at Chimney Rock. The first one I'm going to plan is one that Dave Minkle and I did a couple of years ago, I think 3 years ago now. It was his idea, but I think I helped him to refine the location where we shot from. So 2018, okay. So again, we're going to do this in photopills, and our concept for this was we wanted to take a photograph of the Milky Way above Chimney Rock. So you've got this iconic feature on the landscape. And Dave had figured out that we might be able to do that when just after the new moon, if we had a little bit of moonlight from the west shining on this land, it would illuminate the rock towers and we could try to get the shot. And we did get the shot. And you can see Dave's version of this, I believe, still as a huge print in Suzanne's Art and Framing Center gallery. It's a beautiful photograph that Dave took. Anyway, so let's plan this shot. So I'm going to go back to the iPad and in photopills again, I'm going to load the location that we want to shoot from. So I've got to go to load, point of interest, and in this case, this spot is one I call Chimney Rock Northwest 175 because it's County Road 175. So the red pin is now located where we want to shoot from. And then I'm going to go to the date that we planned this shoot for. So that date was June 18th, 2018. Of course, there's probably an opportunity like this just about every year at about this time. Just saying. And I'm going to set the time to about 10 o'clock in the evening. Okay, so now we have the light blue line was moonrise time. The dark blue line is moonset. At 10 p.m., this thin blue line is the direction of the moon relative to our red pin location. Chimney Rock is, let me zoom in a little bit. Chimney Rock is over here. So let's put a geodetics pin on Chimney Rock. So I'm going to go to the geodetics panel and I'm going to move the black pin up to the summit of Chimney Rock, or as close to it as I can get, probably about there. And it's telling me that it's 945 feet or 6.8 degrees above our observing position. So I'll zoom back out a little bit. So in the map, it's a little hard to see, but you might see this curve of little white balls. Those little white balls represent the Milky Way in the sky. And at the time we've got set, which is 10 o'clock at night, there's a white line from our red pin to the fattest of the white balls, which is right here. Um, and that line is at an azimuth, which is shown over in the panel on the right, down at the bottom here. That biggest white ball is what we call the galactic center. It's sort of the most interesting part of the Milky Way. And that's at a bearing of 140 degrees and about 10 degrees above the horizon at that particular time. Let me move. Yeah, that's good enough. That's close enough. Meanwhile, our geodetics line to Chimney Rock, which is the information's up here, it's at 120 degrees azimuth at about 6.8 degrees. So core of the Milky Way is definitely going to be higher than Chimney Rock at that time. In the Milky Way information down here, it also tells us that the maximum elevation of the top of the Milky Way's arch, which we can see at that time of the year in June, will be at 25 degrees. So that'll be well above Chimney Rock. So we're going to, from that position, we should be able to photograph the Milky Way core just to the south of Chimney Rock, arching above the rock. And that's the photograph that we got. Okay, so that's that demonstration. Now I want to do a variation of this, planning a Milky Way photo at Chimney Rock. And this is the shoot that I have planned for next week, for the 15th, Tuesday evening or Wednesday evening if we have to. We have permission to go up to the top of Chimney Rock and shoot from up there. And near the top of Chimney Rock is the ancestral Pueblo ruins, the Great House of Chimney Rock. And I was out there scouting a few weeks ago, you can see there are a bunch of tourists, and my wife is a tour guide at that point, so she's standing there too. So in this case, I am using the augmented reality mode of TPE. Photopills has a similar ability. Photopills is maybe a little bit more advanced than this for Milky Way, but same idea. And I apologize, this black circle here, I should have gotten rid of that. In TPE, there's this little gray ball that you can position there that's supposed to tell you the direction and color of the light as the day proceeds. Well, at night, it's just this black circle, so it's kind of in the way. But as you saw a minute ago with photopills, the Milky Way is represented by these little white balls. The thickest ball is the center of the Milky Way. So on the night of I actually did this for the 16th, but it's going to be pretty much the same on the 15th. At 8:48 p.m., which is when we get astronomical dusk, the position of the Milky Way will be right here above the Great House at Chimney Rock. So what our plan is to stand next to the Great House, probably put a few lights on it to light it up a little bit, not too much, just enough to see it, and take a photo of the Milky Way above it. And we won't have a hordes of tourists there at that time of the night. We'll have the place to ourselves. So on the other side of this slide, you can see a map view from photopills of that same situation a couple hours later, actually. This one is the 15th. It would be the night we would be there. The red pin is the position that I'm standing when I took this picture. The white line is the direction, the azimuth of the Milky Way. It's arching over us. The gray lines in this case are the rising and setting times of the Milky Way. So we have a period It's actually, in this case, it's not the rising time, it's the time when it's dark enough to see the Milky Way until the core of the Milky Way sets. So we have a couple of hours in there where we have an opportunity to take pictures with the Milky Way directly above the Great House. And I think that should be a very interesting photo opportunity. So that's all I have tonight, and that's probably more than enough. Um, thanks for your attention, and I see a few questions in the chat box, and then if anybody has any questions that you want to ask verbally, you can unmute yourselves and ask those. So questions that I see, a couple of these, Doug has kindly answered. You don't need your latitude and longitude to set a pin in these applications. You can just make a spot on the map. But if you do have a waypoint, you can fairly easily copy those into the applications. It could be a little easier, I will say, but it can be done without too much difficulty with a GPX or KMZ file. Okay, Rob Hagbird says he's going to sign up for Chimney Rock, so that fills that trip. Okay, good, Rob. Okay, any other questions about all of this? And again, I will make the PDF of this presentation available. If you want to ask a question, you can unmute yourself and do so.